Hello. I just want to go over a quick video on merging two sorted lists. This problem I found on LeetCode, and I found it quite interesting, and I'd like to show you guys my solution. Um, so let's get started. Here is the how LeetCode declares their list node, and then here I just created this as a linked list that uses these list node. And here in the main, I already created a two lists and a bunch of nodes, and um, uh, just added them to the linked list. And here we go. The first list is just 1, 2, 3. Second list is just 1, 3, 4. So here we're going to create this is going to be of type list node, and it's going to be a pointer function. This is because we want to return the address of where these new nodes are going to be at in the new list. Um, and here we're going to pass in list node list one. And this as well is going to be a pointer because we want to point to the address of where these numbers are being stored within list node. And then list node list two. And this as well is going to be a pointer. So firstly, we're going to do a list node pointer called new list. And we're going to set this to a new list node. So this is just going to be a dummy list node. I'm gonna say NL new list is equal to, when we say this, new list is equal to new list node, we're grabbing this um part of list node. So new list is equal to 0. Um, and then the next of new list is null. I'm gonna just say N for now, for null. Because this is how we have it declared right here. So let me go back down here. Then we say list node. This is going to be another pointer. Current is equal to new list. So here current is just going to be holding whatever, pointing to whatever new list is. So in this case, 0. Um, current in this function is going to be doing all the work um, to append and to, um, merge the sorted lists. Um, so here we're going to have um, a while loop. So while list one does not equal null PTR, and list two does not equal null or PTR. Um, we're gonna then go into an if statement. If list one list one's current value is less than or equal to list two's current value, we want to add list one's values first. So we're gonna say current is equal to list one. List one is equal to list one next. And else statement, else current next is equal to list two. List two is equal to list two next. And here we're just going to have current is equal to current next. Okay, so what's happening here is in my example, we have in list one, L1 is equal to 1, 2, 3, and then L2 is equal to 1, 3, 4. Um, so what's happening here is while both of these aren't null, we're going to check what while both of them don't reach null. So while there's still elements in there, uh, if list one's current value, so list one's current value is less than or equal to list two's current value. In this case, one is going to be less than or equal to um list two's one. we're going to say current, oh, sorry, not current, current next. Current next is equal to list one. So remember how I said right here, list one is new list right here. We created a new node and pointed new list to that new node. And current is now pointing to new list. What's happening here is current is 0 in the new list, and 0 has a next pointer as well. So this is next 0, and this is next. So what's happening here is we're going to say 0, since current is pointing to 0. 0's next. In this case, it's currently null, but we're going to point it to list our current list uh, uh, value in list one. So current next, 0's next is equal to whatever our whatever this value is. In this case, 1. Pass it up to 1. And then list 1 is equal to list 1 dot next. We're going to move list 1 dot next here. So now in our second iteration, we're going to be comparing 2 to 1. Oh, and then we move, sorry, and then we move, no, I want you to see it. And then we move current. So current, this is all current going right here. This is current. So we move current to 1 now. So now current next is this. We're going to be comparing list 1's value to list 2's value. In this case, list 1's value is not less than or equal to list 2's value. Then we enter this else statement. Then we say current next. So 1 next is equal to list 2. So 1. You have 1 right here. Move list 2's current value to the next one like this. This is what this line is doing. And then move current to the next one. Boom, right there. And now we point again. Now we're comparing 2 to 3. We check again right here. Is 2 less than or equal to 3? It's true. Do what we just did in the previous 2. Put 2 right here. No, I don't like that. Put 2, 2 right here. Move 2 to the next one. Then compare these two together. Move this one as well. Compare these two together. We would put this 3 first. And now this reaches null. This is and there's going to be another, there's 2 more little parts that I have to add to this. When this reaches null, we would just pass the rest of list 2 to here. So we would automatically pass, since they're going to be sorted, since we know they're going to be sorted, we would just pass these 2 last elements onto this right here. So 3 and 4 automatically get passed onto this. So let me just add this real quick. So here we're going to have an if statement. If list 1 does not equal null, PTR. So if there's still elements within list 1, so this is in case list 2 reaches null first, and there's still sorted elements in list 1. We would say list 1 is, if list 1 is not null, we'd say current next is equal to list 1. So we're going to pass all of the rest of the elements of list 1 onto current's next. And the same thing for list 2. So if list 2 still has remaining elements, does not equal null, PTR. Since they're already going to be sorted, we don't have to worry about sorting them. We just pass the rest of list 2 onto current's next. So is equal to list 2. So here in my example, list 1 reached null first. We would go into this if statement, check if, or first we would check this if statement. If list 1 does not equal null, in this case it does equal null, we would pass on to this one. If list 2 does not equal null, remember that list 2 was still on this 3 right here. Current next, let me go back. Um, uh-oh. This is current right here. So current's next. This is null. Current's next is equal to list two. Automatically just pass in these um the remainder of list two. And now for the return function, not for the return, but function, but just for the return, we'd say return new list next. Um, we say this because remember current is pointing to new list. This is essentially new list right here. Just current was doing all the work for new list. Um, new list, if we were to return just new list without the next, it would return the 0 as well. We don't want that because 0 was not part of list 1 or list 2. We say return new list next, which would return from here onwards like this. And it would return this as the new linked list. So here, let's show it off. We're going to say list node. This is going to be a pointer as well. New list is equal to merge list one head, and then list two head. And here we're going to say if new list does not equal null. So if there's elements in new list, list node current is equal to new list. So current is going to be this, so we can cycle through boom, 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 the new list. We say while current does not equal null. So while there's still elements within new list, stdc out current's value followed just by a space. Current is equal to current next. So yeah, let's run it real quick. And let me type out a little message real quick. stdc out merged lists. So here we go, list one, list two, and here is the merged lists. As you can see, it's exactly how I showed you. 1, 1, 2, 3, 3, 4. So yeah, this is essentially it for the merge list from LeetCode. I find it quite interesting, and I hope y'all understood it, and I hope I explained it well. Thank you for watching.